When I started this work years ago, it was actually helping Bill Gates with work with third world diseases, with children dying of diarrheal diseases. And then with Colin 2 years ago now, I guess. I never expected my family to be hit by it, but I think it just shows it can happen to anybody. I'll just tell you what happened in a couple of minutes, because it's really quite instructive. Two hospitals are kind of arguing over who infected him, but one of them did with MRSA. He was in hospital for several weeks. The last 2 weeks of his life, I was visiting him most days. And I spent literally every waking moment when I wasn't visiting, going through the whole medical literature, all the scientific literature on MRSA, trying to figure which antibiotics might work. I'm still none the wiser. I mean, literally, it's a mess. If you go through the scientific literature, it's pretty much random. And I think, as David said earlier, David Warren back there said earlier, we have to just be pragmatic. My advice to any of you would be, if you catch MRSA, insist on getting a swab, getting it to a really good lab, and get them to just test combinations of antibiotics. My father went through 5 standard procedure, none of them worked. Get a swab, get it to a lab, and get it tested and find out what actually will work against the particular organism you've got. 1930s and 1970s, the golden age of antibiotic drug discovery. Only 2 new classes in the last 40 years, and they do not work against gram-negatives, which is why Ed emphasized the real problem with gram-negatives. So 40 years now, no new success in finding any new chemical class working against gram-negatives. As Ed said, they're much more complicated than gram-positives, much more difficult to get anything to work against them. So even if we throw money at this problem, as Jim O'Neill is suggesting, honestly, those of us that know this area can't say we're going to succeed. The research strategy we've put together, which will roll out over several years. Fortunately, through some very generous donations in the last year or so, we've managed to start this now. So number 1 is underway. In fact, we've just started number 2 as well. Number 1 is to repurpose non-antibiotic drugs to add to an antibiotic to break resistance. Now, this came out of a literature review that I started about 2 years ago. I actually started writing a paper for Nature on something quite different. Nature's our top science journal. And halfway through writing that, I realized I was reading things that were probably more important than what I was actually writing. So I completely redirected the article. There's quite a lot of evidence out there in the scientific literature that non-antibiotics, even for some foodstuffs, curcumin is rather interesting. Green tea is rather interesting. I know Dave is working on these as well. Things that you probably wouldn't consider to be drugs can break resistance to some of our antibiotics. So we are currently doing this in a very rigorous way. We have a contract with Evotec, a big contract research organization in Manchester and Toulouse in France. We're testing the whole drug pharmacopoeia in combination with our 4 or 5 most important antibiotics against the most resistant gram-negatives. The second approach is to use combinations of antibiotics, which is what it happens in medical practice anyway. And there is some logic behind what happens, but it hasn't been rigorously exploited. So we're doing that now as well. And I must say, I actually got the first results last week, and it's really quite exciting. We've got some really interesting stuff. The third will be to try and find totally new antibiotics. Now, I'm a drug developer. I've spent 40 years inventing drugs. Mostly failure. I've succeeded 3 times, but most failure. It's very difficult. Antibiotics is probably the most difficult area of all. We're going to go back to the chemical templates that the pharma industry has not exploited thoroughly. In the last 40 years, basically they've given up. They've shelved a lot of things. I was at Newcastle University, for instance, Freeman Hospital in Newcastle, a wonderful hospital, on Thursday, talking to Kate Gould, Professor Kate Gould there, and John Perry. They're doing exactly this. They are taking some parked templates that Hoff and Roche, as it happens, published in the 1980s, showing that this class with a new mechanism that has not been used in humans before breaks resistance wonderfully against these very resistant species. So I think there's quite a lot we can do at quite low risk to bring new antibiotics forward, and that's going to be our third area. So this term antibiotic-resistant breakers is the term we're using to describe when we put a second molecule with an antibiotic break resistance. So here's the general concept. We can reposition other drugs, non-antibiotics, to be resistance breaker when used with antibiotics. So a drug that you might be using to lower blood pressure as an antidepressant or something else might break resistance. That's what we're exploring at the moment, and there's plenty of evidence some of these work. Now, if this ARB antibiotic resistance breaker concept works, it's more than just discovering 1 or 2 or 3 new antibiotics. We've proven a concept that can then be used over and over again. So we could potentially develop at low cost these combinations and salvage many of our current antibiotics. There are about 100 in total, as Ed said. Once we find an ARB that works against one class, one antibiotic in a particular class, the chances are it'll work against others in the class. If the ARB stops working, we've proven the concept, we can then find another one to salvage that whole class again. So I think there's more than just a few products to be discovered here. I think there's a whole concept that could help us a lot in the future.